Hey everyone, Mr. Ahmed here. So I thought I'd make this video to go over the Chantier Calcul 1 Essai 1 from last year, just in preparation for the upcoming Calcul 1 Essai 1 that you guys are going to be writing next week here. So I'm just going to be going over these questions here. Now, you don't have to worry too much about exercise 4. That one's kind of changed for this coming year. I've got another set of questions that we can take a look at that have kind of replaced those questions. So yeah. Anyways, let's get started. So on exercise number 1 here, we're being asked to determine if the result of these operations is going to be either positive or negative. So when you look at this first operation here, you've got a negative 56.02 minus a positive 111.23. Now you might have already seen that, when you're subtracting a positive value, it's actually the same thing as adding a negative value, right? So you would have seen that with your French teacher. So when I've got a negative value and I am adding a negative value or another negative value, well, I'm just going to get a negative answer, right? So yeah, that's kind of that one right here. Okay, this second one right here, so 26 to the power of negative 2. Now, this guy right here is a little different. Now, you might have not seen these negative exponents, but we will be talking about them. I think as of next week, we'll probably start talking about these laws of exponents. But essentially, there's this little cool law that says that if you've got, let's say, x to the power of n, so maybe I'll scroll up so we're not down. There we go. Whoops. Hold on a second. Here we go. Okay, so x to the power of n. Well, I can actually express this guy as 1 over x to the power of negative n. Okay, so essentially what I'm trying to say is that when I've got an exponent, when I've got a power, right? When I say x to the power of n, or I say, I don't know, this x could have been a number, right? Like if I say, like, for example, 4 to the power of 1. Okay, we're going to say 4 to the power of 1. Nah, let's make it fun. We're going to say 4 to the power of 2. Okay, so 4 to the power of 2. Okay, so well, that 4 to the power of 2, I can actually express it as 1 over 4 to the power of, okay, I'm just following this guy right here, 4 to the power of negative 2. Okay, now that also means that if I have, I don't know, 3 to the power of negative 3, okay, I can express this guy as 1 over 3 to the power of positive 3. Okay, so you've probably noticed that kind of the rule is you're flipping this guy down into the denominator, right? Because right now he's in a numerator, right? This guy's technically over 1, right? All of these are technically over 1, right? This guy's over 1, that guy's over 1, right? So what you're doing is you're actually grabbing the numerator, you're flipping it down into the denominator, and then you're changing the sign on the exponent, okay? So instead of having 3 to the power of negative 3, you're now going to have 3 to the power of positive 3. Okay, so that's kind of that rule. I don't want to get too much into it. I am going to talk about it next week when we start talking about those exponent laws. But yeah, for now, kind of just realize that when I've got a negative exponent like this, it just means that I can flip this guy into kind of like a fraction, where now I can flip it into a denominator, right? So that guy's going to become 26 down in the denominator, and then that exponent is just going to have now the opposite sign. We originally had a negative, well, now it's going to be a positive. Okay. Alrighty, so that's 1 over 26 to the power of 2, which is a pretty big number. So when you go 1 divided by 26 to the power of 2, you're probably going to get like 0.00 something, right? Like 0.001 something. And then that tells you, though, that although it's a very small number, it's still a positive number. Okay, so this guy right here is actually going to be positive. Okay. All right, let's take a look at this guy here. So here we've got negative 1 to the power of 9, and then that over negative 2 to the power of 4. Okay, well, that's interesting. Okay, so I've got a negative value to the power of 9 and a negative value to the power of 4. All right, well, let's take a look first at, what happens when I say negative 1 to the power of 2. Let's see what that comes out to, right? Well, negative 1 to the power of 2, you know that to the power of 2 means that number times itself, right? So this means negative 1 times negative 1. Okay, well, a negative times a negative is a positive. Okay, so my answer for this is going to be positive, and it's going to be 1. Okay? Now, let's say that I had negative 1 to the power of 3. Okay? Well, if I had negative 1 to the power of 3, that means negative 1 times negative 1 times negative 1. Okay, well, I know what negative 1 times negative 1 gives me, right? It gives me positive 1. I did it up here. So all I have to do is I have to take this guy and multiply it by another negative 1, right? So a negative 1 times a negative 1 gives me a positive 1, and I multiply it by another negative 1. Well, then that gives me negative 1. Okay, let's take a look at negative 1 to the power of 4. Okay, so negative 1 to the power of 4 means I just have to take this negative 1 to the power of 3, this answer, which is negative 1, and just multiply it by one more negative 1, right? Well, negative 1 times one more negative 1, that's going to give me a positive 1. Okay, so maybe you're kind of noticing a pattern here, right? Maybe I'll give you a second to think about it. Alrighty. So now that you've thought about it, what you're realizing, hopefully, is that it looks like when the exponent is an even number, your answer is going to be positive. Okay, so we can actually see that with this guy right here, to the power of 2, and we can see it with to the power of 4, right? To the power of 4, we've got a positive 1 as an answer. To the power of 2, we've got a positive 1 as an answer. So whenever you have an exponent that is even, your answer is always going to be positive, regardless of whatever's down here. Okay, whether it's positive or negative, whatever's down here, the base, doesn't matter. If the exponent is even, your answer is always going to be a positive value. Okay, but if your exponent is odd, right, like 3, your answer is going to be a negative value, right? And we can actually see that. Like if we had continued to negative 1 to the power of 5, right? Well, what does that mean? Well, it means we take this guy, which is negative 1 to the power of 4, and we just multiply it by one more negative 1, right? So when we multiply that guy by one more negative 1, well, that's a positive times a negative. That gives me negative 1, okay? So when you have even exponents, the answers are always positive. When you have odd exponents and when the base is a negative, your answer is going to be a negative answer, or a negative value, okay? So when I take a look at this guy, this is negative 1 to the power of 9. 9 is an odd number. So that means that that guy comes out to a negative. Okay? Now this is negative 2 to the power of 4, and we said that anything to the power of 4, whether it's a positive or a negative number down here, right? Like if the base is positive or negative, doesn't matter. Anything to the power of an even number is going to be positive. Okay, so here you've got a negative value divided by a positive value. Well, that's going to give you a negative value, and that's why this guy right here is negative. Okay, and well, this guy ties into what we were just talking about, right? This is a negative value in the base, and then in your exponent, you've got an odd number. So again, a negative down here to the power of an odd number, that's always going to give you a negative. Okay, alrighty. Now, what if this guy was 2026? Right? Well, if that guy was 2026, that's an even number. So, like we said, doesn't matter what your base is. If your exponent is even, your answer then would be positive. Okay? Alrighty, let's take a look at this down here. So, soit f et g, deux nombres non nuls de signe contraire. Okay, so f and g are two numbers. They're not zero, and they have opposite signs. And now they're asking, what is the sign of this guy? Okay. All right, so we said G and F are two numbers. One of them is positive, the other one's negative. It doesn't matter which one of these we say is positive. It'll actually give you the same answer. Let's say that G is positive. We're going to say G is positive, and then we're going to say F is negative. Okay? So here, if I've got 7, which is a positive, times G, which is a positive, my answer is going to be a positive. Okay? And down here, I've got a negative 3 times F, which we said was negative. So a negative 3 times a negative, that's going to give me a positive, right? We know a negative number times a negative number is a positive answer, okay? So a positive divided by a positive, it's going to give you a positive answer, okay? And you can try it backwards, right? You can try it with G being negative and F being positive. You're going to get the same answer there as well, okay? It's going to still be positive, okay? Alrighty. Let's move on to this guy down here. Now, soit E un nombre négatif, le signe de that est Okay, great. Well, we've actually talked about the fact, I think I repeated it several times now, it doesn't matter what your base is, right? As long as your exponent is even, your answer is always going to be positive. So bam, there you go, it's positive. Okay. Now here they're trying to get a little tricky though. Here they're saying soit E un nombre négatif. So E is actually it's Euler's number. You don't have to worry about that for now, but they're just saying let E be some random negative number. Okay, well, le signe de that is what? Well, this actually is already negative, so they're just trying to be a little tricky here. There's already a negative out here, and now they're saying E is a negative number, so this is actually a double negative, right? So this is a minus minus E to the power of 2. Now, obviously, I would have put a bracket here just to have that looking a little better. Kind of running out of room, though. So this actually translates to just E to the power of 2, okay? Which would therefore just be, a positive number anyways. Okay, so that doesn't really matter, but yeah. Now, it would be interesting to explore what would happen if we change some things up here. So soit E un nombre négatif. You know what? Let's make it positive. Let's say this is positive. Okay, so positif. Okay. And then we're going to say that we are going to drop these parentheses. Okay, we're going to drop these parentheses. We're going to say that this is happening instead. Just negative E to the power of 2. Okay, what's the answer there? Right? Is this still going to be positive or is it going to be negative, or what's happening? Okay. All right. Now here's the deal. When you drop the parentheses, the order of operations kicks in, right? Well, I mean, it's always kicked in, right? You had to do an exponents here, but that's all you could do. But when you've got no parentheses here, what has to happen first is that you actually have to raise the E to the power of 2 first before applying the negative. So this negative is actually going to be applied to the result of E to the power of 2. Okay, so however you know your order of operations, BEMDAS or BEDMAS or whatever, that exponents are really right up there with parentheses. They're one of the most important operations to do before you do any form of multiplying or dividing or adding or subtracting, right? So according to BEDMAS, you've actually got to raise the E to the power of 2 first before taking this negative into consideration. Okay, so when you go E to the power of 2, and if E is a positive number, okay, well, that gets you a positive value. And then that value is, oh, hey, it's being, well, you apply the negative to it, therefore it's going to be a negative value. Okay? Okay, so hopefully that makes sense. So there is a big difference between having the brackets and not having the brackets. Okay? So maybe I'll just erase this here. Okay? If you have the brackets, and let's say that E is a positive value. Okay, let's say E is a positive value. If you have the brackets, this is going to be negative E. Let's say E is 3. Okay, we're going to say this guy's 3. You're going to have negative 3, but because you've got the brackets, this to the power of 2 literally means negative 3 times negative 3. Okay, well, negative 3 times negative 3 is a positive 9. Okay, but here, negative E to the power of 2, this means you're saying E to the power of 2 first. So let's say this was 3. 3 to the power of 2 first, which would be 9. Oh, hey, by the way, that's negative. And then you'd get an answer that's negative. Okay, negative 9. Okay, so hopefully that makes sense. Let's move down into exercise number 2. Alrighty, so exercise number 2 here, simplifie au maximum les expressions suivantes. So essentially what you're doing here is you're looking at all this stuff here and you're trying to combine like terms, okay? You want to combine the terms that are, resemble each other. Now, for example here, I've got a negative 82a and I've got a 41a. I like, when I see a, I just like to think of apples, right? This is like negative 82 apples and 41 apples, okay? These are like terms. So I can actually combine these by just adding them together. So I've got negative 82 plus, negative 82a plus 41a. Well, negative 82 plus a plus 41a, that's going to give me negative 41a. And I've also got 31 minus 17, and those are like terms as well, and that gets me 14. Okay? So 14 minus 41a would have been your answer. You could have also written it backwards by saying minus 41a plus 14. Okay? This guy right here, same thing. You have to combine the like terms. Now, before you do, there's a little a little multiplication that you've got to do here. You've got to do the applied distributive property, which means that you've got to actually distribute this 5 into the parentheses. Okay, so you've got to multiply 5 by 7, and you've got to multiply 5 by negative 7b, and that's kind of what we do here. So 5 times 7 is 35, and 5 times negative 7b is negative 35b. Okay, and then now, well, as of that point, it's the same exact kind of question as this guy. You've got to combine the like terms, so negative 75b and negative 35b come out to negative 110b. And then you've got the negative 75 plus 35. Well, negative 75 plus 35 is going to come out to negative 40. Okay? Alrighty, moving down into example number 3. So, for example number 3 here, we're being told that x is equal to negative 3. Calculer en indiquant les étapes nécessaires, and then here you go. Okay, so you've got this guy right here, so that means that I'm going to have to take x, I'm going to take negative 3, and plug it in place of the x's here and here, okay? So when I plug that in, here's what I get, okay? Now, remember, you have to apply BEDMAS or BEMDAS, or however you learned it, okay? Now, according to that list of order of operations, right, the exponents are first. Okay, so that means I've got to do negative 3 to the power of 2, that gets me 9. Okay, now after my exponents, I've got multiplying and dividing. Okay, well, I do have some multiplying happening, right? I've got multiplying happening with 3 times x, and I've got multiplying happening with the 2 times 9, right? Negative 3 to the power of 2. Okay, so I've got, well, negative 2 times 9, so I'm just going to leave that as is. Negative 3 times a negative 3 gives me a positive 9. Okay, so right now at 15 plus 9 minus 2 times 9. Now again, order of operations tells me I've got to do that guy first. Ooh, that's a little chunky there. Here we go. Right, this is the more important operation. I'm not going to add first. Okay, I mean, it doesn't really matter, but I'm not adding first. Okay, I've actually got to do this multiplication first. Okay, so I'm actually going to get 15 plus 9 minus 18. Okay. 15 plus 9 minus 18, you can just do that however you want. That's going to come out to 6. Okay? So there you go. That's that question. Now I did say for example number 4, you don't really have to worry too much about example number 4 here. Just because a lot of this stuff was kind of looking at laws of exponents, which we haven't really talked about yet. So instead, we're going to be talking about some of these questions. I'll talk about these questions first, and then I'll move down into exercise number 5 and 6, and then that'll be the end of the video. Okay. Now this guy here, I talked about that earlier, right? When I was talking about Euler's number over here, this guy right here, right? When I was talking to you about, oh, okay, you know what happens when we drop the parentheses and all that. So for something like this, actually, let's do this guy first. This guy right here, we know that that guy is going to be negative 3 to the power of 2. That means negative 3 times negative 3. Okay, that means positive 9. Okay. But this guy, remember, I just kind of told you this, 5 or 10 minutes ago. I said, when you've got something like this where you don't have the brackets or the parentheses around the negative value, right? I'm sorry, I can't really say the negative value, but around this negative 3, if you don't have parentheses around it, what you have to do is you have to say, okay, well, you know what? According to BEDMAS, I've actually got to do my exponents first. So 3 to the power of 2 is 9. Oh, hey, that 9 happens to be negative. So then your answer here would be negative 9. Okay, so a very important distinction here. Okay. Now here I'm asking you to express this using index form. Now, index form just means using exponents. Okay, so like having a base and then a power and then that's it, right? So you're just using your exponents. Essentially, there are the exponent laws, loi des exposants, that we will eventually talk about next week, and you can answer them obviously with loi des exposants, but you don't really need it for that, right? Because when you look at this, like think about really what does this mean, right? Like 3 to the power of 12 divided by 3 times 3 times 3 times 3, like this is technically a fraction, right? You could say you've got like 3 to the power of 12. That means you've got 3 times, oh gosh, this is going to be long. 3 times 3 times 3 times 3, okay, times 3 times 3. Okay, I think you're getting it. We've got 3 times itself about 12 times in the numerator, okay? And then in the denominator, you've just got 3 times 3 times 3 times 3. Okay, so I've got 3 times itself 12 times happening in the numerator, and then 3 times itself here 4 times. Okay, so what I could do is I can maybe go like, oh, hey, you know what? I think I can cross some of these out, right? I can cancel some of these 3's out with each other. And that's exactly what you do. And then there you go, you're done. You're done. Now, how many 3's do you have up here? Well, we used to have 12 of them. We canceled out 4. So my answer is going to be 3 to the power of 8. Okay, and that's literally your final answer, right? That's it. You're done. Your answer is just 3 to the power of 8. We canceled out 4 of the 3's up here with these 4 3's down here. Okay? Alrighty, let's take a look at this guy right here. So 8 to the power of 8, and then over 8 to the power of 0. Okay, well, using that same kind of idea, I've got 8 8's in the numerator, and I've got none in the denominator. Are any of those 8's going to cancel out in the numerator? Well, the answer is no. I'm not going to be able to cancel out any of them. So my answer is actually just going to be straight up 8 to the power of 8. That's it. That's my final answer. Okay. Now, you can also maybe sort of, I mean, you've probably already seen this before, I don't know, but any number to the power of 0 is actually just equal to 1. Okay, and that's just kind of a little rule that you're gonna kind of get accustomed to. Anything to the power of 0 is just equal to 1. So when you've got something like this, you could actually just say, oh, well, you know, that just means 8 to the power of 8 divided by, oh, hey, you know, anything to the power of 0 is 1. So, okay, great. Well, 8 to the power of 8 divided by 1, well, that's just 8 to the power of 8. Okay, so hopefully that makes sense. And we go down to this guy here now, 169 times 13 to the power of 5. And you might be looking at that and it might kind of scare you a little, but it shouldn't. And maybe it'll stop scaring you as soon as you realize that 169 is actually a perfect square, right? It's a perfect square. 169 is 13 times itself, right? 13 to the power of 2. Okay, so that means this guy is actually 13 to the power of 2, and this guy is, well, 13 to the power of 5. Now, again, there are some rules with exponents here, but we don't really need to know them, okay? Why? I mean, I'll talk to you about them next week, but for now, you don't need to worry about them. 13 to the power of 2, that just means 13 times 13, right? And then 13 to the power of 5 means that you're just going to go times 13 times 13, you know, 5 more times, right? So times 13, might as well just write them all, times 13, and then times 13. Whoopsie, that one's a little funky. But anyways, so I've got 13 times 13 times, 13 times 13. This guy is this guy right here. And I've got 13 to the power of 5, which is 1, 2, 3, 4, 5, which are these guys right here. Okay, so all of that is just equal to 13 to the power of, and then you just count it. 1, 2, 3, 4, 5, 6, 7. Oh, that's 13 to the power of 7. And maybe you're looking at this right here and you're just like, oh, I think I know what that rule is. And if you're thinking that the rule is you add these exponents, you're absolutely right. Okay, that is the rule. You're going to go 13 to the power of 2 plus 5, which is 7. Awesome. Okay, great. Let's keep going. Oopsie, there we go. Okay, now we're being asked to calculate this guy. Ah, geez. Okay, calculate this. Now, maybe you have memorized your list of perfect cubes, right? So remember I gave you guys a list of perfect cubes, the first, first 10 perfect cubes, right? So 1 to the power of 3, 2 to the power of 3, 3 to the power of 3, and so on. And then I also gave you a list of the first 20 perfect squares, and I do recommend that you memorize those. It's just going to make your life a little easier with this kind of calculations. Now, if you do remember those, you'll also remember that the cube root of 216, that this guy actually is 6 to the power of 3. 216 is 6 to the power of 3, right? So the cube root of 216 is just going to be straight up 6, okay? Now, if you don't remember that, what you could do is you could do what we saw in class, which is do prime factorization, right? So I do I set up the prime factors of 216, right? So I divide 216 by 2, I'm going to get 108. I divide that by 2, I get 54. I divide that by 2, I get 27. I divide that by 3, I get 9. I divide that by 3, and I get 3. Okay. So that means that I can express this guy as the cube root of 2 times 2 times 2 times 3 times 3 times 3. Okay, so I could actually rewrite that as this. So I'll just rewrite it like this. So the cube root of 2 times 2 times 2 times the cube root of 3 times 3 times 3. Okay, we saw this in class, right? Okay. And so because I can rewrite this guy like this, well, you know, this is actually really convenient because the cube root of 2 times 2 times 2 is just going to be 2 itself, right? Because cube root is just asking you, hey, what number times itself gives me this number? Well, it's actually very nicely already split out for you. It's 2, right? Or if you're unsure, you can just go, okay, well, what's 2 times 2 times 2? 2 times 2 is 4. 4 times 2 is 8. And you're going to be like, okay, well, the cube root of 8, well, what number times itself gives me 8? Oh, hey, that number is just 2. Well, there you go. Okay. This guy right here, same thing. That guy is going to be 3, right? The cube root of 3 times 3 times 3, that's going to be 3. Okay, so 2 times 3, well, that's just going to be 6. Okay, so there's your answer. Okay. That's in case you ever forgot that this guy, you know, was a perfect cube and that 6 to the power 3 is 216. Okay. Alrighty. Let's scroll down to this guy over here. So the square root of 7 times the square root of 7. Well, you know what? We just saw it from the above example, right? You can actually oh, that one's no good. You can combine those two together under one square root, right? That's going to be 7 times 7. Oopsie. Here we go. Right? That's going to be the square root of 49. And the square root of 49 is, well, that's just 7. So your answer is actually just 7 for this. Okay? Okay, now for this guy here, this guy is a little trickier. Okay, now this guy also, you know, laws of exponents, change of base, you know, we'll talk about that stuff maybe as of next week. But for now, what you can maybe sort of realize is that 25 to the power of 4 means the same thing as, well, I know that 5 is, or sorry, I know that 25 I can express as 5 to the power of 2, right? I'm expressing 25 as 5 to the power of 2, and that to the power of 4, right? Okay. Okay, so I'll just make that a little bigger here. Here we go. Okay, so I've got 25 to the power of 4, which I've expressed as 5 to the power of 2, which is 25. That to the power of 4. And then in my denominator, I've got 5 to the power of 3. Okay, 5 to the power of 3. Now, again, there are exponent laws that would make this a lot easier. But you can also kind of just think about this and be like, well, I've got 5 to the power of 2, and then times itself 4 times. Okay, that means 5 to the power of 2 times 5 to the power of 2 times 5 to the power of 2 times 5 to the power of 2. Okay. All of that over 5 to the power of 3. Okay. Well, 5 to the power of 2 times 5 to the power of 2 times 5 to the power of 2 times 5 to the power of 2. Well, this actually just means 5 times 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 5. Oh, okay, so 5 times itself 8 times. Okay? Or you'll remember from earlier that rule was you're just going to add those exponents, right? When the base is the same, you're adding those exponents. 2 plus 2 plus 2 plus 2 is 8. Okay? Okay, so I've got 5 to the power of 8. So I've got 5 times 5 times 5 times 5 and so on and so on. Okay? Over 5 to the power of 3. Okay? So that means that I've got 8 5s in the numerator and I've got 3 5s in the denominator. Well, those 3 5s in the denominator are going to cancel out with 3 of the 5s in the numerator. And then that leaves behind only 5 5s left in the numerator. So your answer is just going to be 5 to the power of 5. Your final answer, really, like if you were just to lay this out as just 5 times 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 5, and then in your denominator, you're just going to lay that out as 5 times 5 times 5, and then you just cancel out 1 5, 1 5, another 5, another 5, and then a third 5, another third 5. You're going to find that you're just going to have 5 5s left in your numerator. So that's going to be 5 to the power of 5. Okay? Alrighty then, and finally, well, no, not finally, because I've got some other examples on the other page, but finally on this page, on these other side examples here, square root of 260, and we're asking you to estimate, right? So again, remember, this is kind of why it comes in handy for you guys to actually know and memorize the first 20 perfect squares. If you've done that, then you'd realize that the perfect square that comes before 260 is 256, and the perfect square that comes after 260 is 289. Okay, so remember that we do have a couple of steps that we have to write down to really show our work. Okay, you can't just come up and just write down, oh, you know what, I think it's between this number and that number, and that's it, right? If you do that, you're not going to get any marks for communicating. So to get full marks for communicating and all that, what you have to do, and for it to count, for whoever's grading your Chantier Calcul to consider this a correct answer, what you're going to have to do is you're actually going to have to show the steps. Okay, so the first step is actually going to be, I don't know why it keeps doing that. It keeps, there we go. Okay, we're going to fix that hopefully. There we go. Okay, so the first step is you're going to first identify those perfect squares before and after. So you're going to say, since we said what was it? It was we said it was 256. Yeah. So we're going to say since, now 256 is actually the result of 16 squared. Okay. So since 16 squared equals 256, and 17 squared, oopsie, there we go, equals 289. And since, okay, and then you're going to say, and since 256 is less than 260, which is less than 289, then it follows that the square roots of these would also follow the same pattern, right? That means the square root of 256 is going to be less than the square root of 260, which is going to be less than the square root of 289. Okay. Well, the square root of 256, we know that that's 16. That means 16 is less than 260, or sorry, less than the square root of 260, which is less than 17. Okay? So then that would be your final answer, but you're not going to get full marks unless you show these 4 steps, okay? So again, these 4 steps, I think I'm kind of talking to you guys nonstop about them. So here you go. All right, so that's what I wanted to do on this page here. Now I'm jumping back to the Chantier Calcul here. So we can go ahead and skip example number 4, okay? And now we can just kind of go down to these values here, or these exercises here. So these ones are relatively straightforward, right? This is work with directed numbers or integers, however you call them. But essentially here, all you're doing is you're applying bed mass, right? And then you're taking care that you're assessing these negative values with positive values properly and so on. Okay, so here for example, you've got an addition and you've got a division. BEDMAS or BEMDAS tells us that we've got to look at division first. We've got to do that one first. Okay, so 55 divided by -5, that's -11. Well, I've got -311 minus 11, so then that means I'm just going down to -322. Okay. Looking at this guy right here, so remember that BEDMAS tells you that the parentheses are most important. So what you're going to do is you're going to evaluate what's in the parentheses first. So 21 minus 38 is -17, and then -3 plus 5 is 2. Okay, Now I've got negative 255 divided by this guy plus 2 times this guy. So I've actually got to do the division and the multiplication first. Okay. Now dividing and multiplying are actually equal operations. Okay. So it doesn't really matter how I do this as long as I just do them. I don't add them together first. Okay. That's the important thing here. The important thing here is I just figure out an answer for this guy right here. Then I figure out an answer for this guy right here, and then I go and add them together. Well, negative 255 divided by negative 17 is going to give you a positive 15, and 2 times 8 is positive 16. Okay, well, 15 plus 16 is 31. Okay? Now, this guy right here, same thing. Oh, so careful, right? You've got a negative 14. Now, notice that you do have the brackets around the negative here, but you don't have it here. Okay? So negative 14 to the power of 2, that's 196. Except we're subtracting it, right? This negative drops here. That negative is this guy right here. So 11 minus the result of negative 14 to the power of 2, which is 196. Minus the result of 12 to the power of 2, which is 144. Okay? So if you do this properly, you go in 11 minus 196 minus 144. You do your little calculations. That should come out to negative 329. Okay? This guy right here, I'm just not going to do this one because I did go over one that was like that. It was this guy right here. Same idea, right? You're changing that base. Okay, I guess maybe I'll just go over it real quick. You're just changing that base, okay? This guy right here becomes a 3 to the power of 2, okay? Now 3 to the power of 2 to the power of 4 means I've got 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2. That means 3 times itself 8 times, and that's why we've got a 3 to the power of 8 over here. Up here I've got a 3 to the power of 9. So if I've got 9 3's happening in my numerator, right? I've got 3 times 3 times 3 times 3 and so on 9 times. And down here I've got that happening 8 times. Well, 8 of the 3's are going to cancel out with 8 of the 3's down here. And that's going to leave me 1 3 up in the numerator, right? Because the numerator's got 1 extra 3, 1 more 3 than the denominator, right? Because this guy right here is a 9 and this guy's an 8. So I can cancel out 8 of those 3's, right? Like 3 times 3 times 3 times 3, 8 times, and I can cancel that out in the numerator, same thing. But then I'm only going to have 1 3 left in the numerator, so that's why my answer is just 3. Okay? And then finally, exercise number 6. So, soit U et V, deux nombres tels que UV égale moins 88, calculer les nombres suivants. So here, so I know that UV is actually a negative number, but then I've got a negative out here. Okay, so negative, I've got a double negative happening. So minus 88, well, that's just going to be a positive 88, plus 218, and that I'm going to have to do that first, obviously, because those are in parentheses, and BEDMAS tells us we have to do the parentheses first. And when I take those and I add them up and then I divide them by 18, I get 17. Okay? This guy here is looking a little funky just because we're not getting the clear UV in there, right? So all you have to do is you actually just have to factor out the V, right? Like just bring out the V, put it with the U. That's going to leave behind negative 3, okay? So you've actually got negative 3 over negative 16 times UV, right? You just pull out that V out here, okay? And that's why I have this, okay? Now, negative 3 divided by negative 16, well, that's going to be positive. So that's why this is 3 over 16, okay? And then, well, that's just going to be 3 times negative 88 over 16. Now, we can separate the negative 88 into 8 times 11. Now, where did the negative go? It went out here. There it is. Okay, so it's still a negative, okay? That negative belongs to the negative 88, but, it's not going to change anything, okay? So you can, again, we were saying we were factoring out the 88 into 8 times 11, and then you can factor out the 16 into 8 times 2. The 8's cancel out, right? So you're left with negative 33 over 2 as a final answer, which is negative 16.5, okay? And that's it. That's what your Chantier Calcul is going to look like. Hopefully this was helpful. Thanks, guys. Take care, and bye-bye.